and I do an IRET. When I do an IRET, you start executing back at this point. And now your ES:0 should work correctly, because it should not move ES comma AX should work correctly, because now it has become privilege level 3. Now we go to ES:0 in line 97. What I do, in line number 97, I am moving ES:0. So what is ES actually? ES has E3 now. E3 is what? So E3 is a PL. Now it's a PL3 segment. So it's C1700. So in 0x C1700, I need 0x also check that 0x D0 E4 has a PL change. Now what is D0 E4 currently has? The D0 E4 currently has 40B200, and that will become 40 FF00, F200. So this should change. So also check, it will change from 0x 040B200 to PL3. Currently it is PL1. Okay. Now when this happens, let us now go down. So we have finished this. Now we move AX comma 0x33. So let us see what is there in 0x D0 B3, D0 30. This is a E1300 segment with it's a privilege 3 segment, E1300 with base 0. So E320, I am moving line number 110, 109. Your GS is 0x33. Your line number 100 and E320, line number 110. Your 0x E320 should actually become 0x CFEB00C. Right, and then I do an IRET. When I do an IRET, this basically goes to the fellow who called me. Who called me? This is the fellow who called me. So I go to the instruction next to IRET. This IRET will take me to the fellow who called me. So next to the fellow who called me. So that is this line number 71. So I go to this IRET. This IRET will take me to the fellow who called me, which is this, and from there I jump to ChanHappy. So this is the entire code, and then we do all the other things from ChanHappy. Okay, right? So from there, when you see here, we see that your your D208 should become zero x DECE. Your D200 should become 0x E, and your D208 D208 should essentially become 0x CAFE. So this is annulled because D208 is, so this is annulled. Okay, and then that's it. So it ends. So this is the entire execution of your thing. So let us just go to the front and then see. So this D200 is now changed. So you will not see def. So this should go out. So and this D208 should also change. Okay. And so let us see quickly what are all the things that are going to happen, and then we will also see what are the things that could happen here. So let us go and execute this. These errors do come. You can just try with a reduced baud rate. Instead of 38400, you could have 19200, and sometimes it will work much faster. Yeah, so this is done now. So let us go and check from the back. So your D208 yes, it has cafe, and this has BAB, and let us see. I'm just looking at this and this. Let us see what is happening to your E320. This B00C, yes, this is working. And D0E4, your privilege level has to have changed. Note that it was 40B2, now it has become 40F3. F is the privilege level 3, and this access bit has become 1. So this is F is privilege 3. I have changed it to privilege 3. Then only that particular instruction would have worked. Now let us see what is there in C700 is wavecurve, and then what is there in E020. This is the latest version of VirtualBox. So it has 90. It has only the null code. This particular thing did not push it correctly. Similarly, the stack around the segment should have worked here. So C450. So let us see x/10x 0x C040, right? So as you see here, there has been some pushing here, 53, 50, BB7, etc. So these are the stack corresponding to the 0 stack. So when we switched when the interrupt service routine was at task 0, please note on your right hand side I am showing this 0x68 stack was used, though the process which created that interrupt was a PL3 process, but this is actually using a PL0 stack. right? And then let us go forward and see what. Now again, when we did that call gate, yeah, the stack around this C050 was actually doing that. So it is using that stack, which is to be used always here. Though it was, the original stack was in C1300. If you see the PL3 stack, as you see, was C1350. So let us say S/10X C1340. That stack is never touched. It's still null. 90 is null, right? So when I did a call gate, please note that I have touched the stack which is around the C050 stack, which is the PL0 stack, because the call gate, the called function works at PL0, and so all my data that I pass to the call function, I put it in the PL0 stack and not the PL3 stack. This is very, very important from both a security and protection perspective. Now let us go and see also that what is there in line 0x E040, and there you see ABCD done. E220, that is Cafe Babe, yes, done. E120, that is face B00C, done. So all the code has executed as per what we have seen here. Before we wind up, let us go and have a look at the the different segment descriptors. So let us go and see what is there in S slash, say, some 60x 60x slash 70x 0x, not 70. So each x will give me 4 bytes. So 104 by 4 is 21. So 21x, S slash 21x 0x B400. This is the interrupt service routine task gate. Please note that your so please note that your EIP, which was B420, is now 842, because it started executing at 8000 and this is 842. Your 48 B440 48 is 10, your ES is 10, your CS is 8, and your SS is C8, and so on. So actually I should put it as your DS is 18, or 8, SS is C8, DS is 18, your FS and GS has become 18. Please note that you made GS 18 as a part of your interrupt service routine. Note here in line 139 you made GS 18 and that is reflected. And 842 is this line. So one small thing that you can also do when we are doing this, you can also say minus L $1.lst. So when you compile this, you also get this LST file, lab4.lst. So let us see what is there in lab4.lst. Now this should also give you the actual code. So just note that if you come to, so this gives you the IP address, sorry, the EIP address, the instruction pointer address. This is the, so this is the instruction pointer, and this is the actual compiled machine code for SGTT. So this is a very good utility. Now we see there, if we go to the interrupt service routine, this is where done GPF. Your IRET is at 841. Please note here. The line number, your IRET, which is here at 841, right? So that is why when you went back, your return address was 0x842, right? So return address, what you see at B320, B420 is, you see here is 842, right? Similarly, let us see what has happened to the thing at B300. It essentially says that you need to, your return address will be B320, it is saying 2A, right? 2A is for your TSS3. Your TSS3, now let us see where is TSS3 ending. Yeah, your TSS3 was ending at here, and your starting address was A600 and the offset was 2A. So 29 it ended, so 2A is what is logged there. So this is basically to tell you that how the TSS gets updated. Similarly for your B200, you can also see some specific values being put here, and similarly you can do it for your B1100 also. Right. So this is how it is there, and this is B1000 for your current start. Right. So this is how task switching has happened, and we had gone from privilege level 1, 2, 3, 0 to 1 to 2 to 3, and then there we had done a task call gate and came back. We got a GPF and we handled the GPF and we came back, and then we came back from 3 to 2 to 1 to 0, and there we have also demonstrated the most important aspect of stack switching, and also all the privileges that are privilege checks that are happening when I move from one to another. And I can, so if I have an authentication to move from PL3 to PL0 through a call gate, I am able to successfully do it. But if I don't have an authentication, I cannot go and check a lower privilege object, namely in this case a data segment where I am caught by a general protection fault. So all these things put together should serve as a very important very important input for you to understand the architectural aid that is provided for security purposes. If the operating system, whichever the operating system be, utilizes these features in a proper way, then there is a chance that we could build highly